Trigonometric functions, sine, cosine, and tangent. The trig functions are functions used to relate angles of right triangles to the ratios of the sides of the triangle. It was first developed for astronomy 2,000 years ago by Egyptians, Babylonians, and Greeks to describe the paths of the 7 recognized planets. Trigonometry goes well beyond space. It has applications in navigation, engineering, physics, and meteorology, just to name a few.
Soh Cah Toa.
You may want to remember this acronym, Soh Cah Toa. Sine of the angle equals the opposite leg over the hypotenuse, cosine of the angle equals the adjacent leg over hypotenuse, and the tangent of the angle equals the opposite leg over the adjacent leg. Here we have right triangle ABC, and I'm showing the equations that will work for angle A, as well as angle B. Notice that the tangent of A and the tangent of B are reciprocals of each other, and cosine of angle A and sine of angle B are equal, as well as the sine of angle A and cosine of angle B. We cannot use the trig functions for the 90-degree angle. So let's do some example problems. Solve a variable. So we're given a right triangle with angle A being 20 degrees, the opposite side being x and the hypotenuse 12 feet. So we're going to use sine for this. Sine of the angle equals opposite leg over hypotenuse. We're going to substitute 20 in for angle A and 12 for the hypotenuse. The function will relate the angle to an equivalent ratio. Essentially, this is a proportion. So I want to solve for x by getting rid of 12 by multiplying. That's the inverse of dividing. And I go to my calculator, 12 times sine 20, and I get 4.1 feet. Be careful on the calculator and make sure you're in degrees, not radians. Okay, box that in. Example 2. We're going to have another right triangle. This time we have angle B is 53 degrees and the adjacent leg is 5 inches and the hypotenuse is the unknown, is z. So in this situation I'm going to use cosine. Cosine B equals the adjacent leg over the hypotenuse. Cosine 53 equals 5 over z. My unknown is in the denominator this time, so I need to get z out of the denominator by multiplying it to both sides. Now cosine 53 is a number just like any other, so the inverse operation of multiplying is dividing. So I'm going to divide cosine 53 to both sides, and I go to my calculator, 5 divided by cosine 53, and I get 8.3 rounded to the nearest tenth. So that would be z equals 8.3 inches. Box it in. Example 3. This time I'm looking for my 2 acute angles of my right triangle, and I know all 3 sides. So in this case I can use any one of the equations, Soh Cah Toa.
Soh Cah Toa.
Notice sine and cosine ratios will always be less than 1. There's no way that one of the legs would be greater than the hypotenuse, but the tangent ratios can be anything. So let's go with a sine x equals 15 over 17. I need to use the inverse operation to get rid of sine. Inverse sine looks like sine to negative 1, but we don't say that. We say inverse sine or arc sine. The inverse sine of 15 over 17 is 61.9. Now I can go back and use one of the other equations to find y, but I know the sum of angles of a triangle is 180. So I can just subtract 61.9 and 90 from 180 and get 28.1 degrees. Box everything in and I'm all done. I hope you enjoyed this presentation on Soh Cah Toa.
Soh Cah Toa.